Hello everyone, in the last video we saw how indices help us simplify repeated multiplication of a number by itself. So instead of writing out long multiplication, we used exponents or powers to make things easier. But what happens when we start working with expressions that involve multiple indices? Do we expand everything again, or is there a smarter way to simplify them? Well, that's where the laws of indices come in. We start off by looking at the first law, which is the multiplication law. This law states that when multiplying two numbers with the same base, but possibly different indices, we add their indices while keeping the base the same. Now let's look at why that is true. Remember that we learned that a to the power of m is basically a multiplying itself m times, and a to the power of n is a multiplying itself n times. So a to the power of m multiplied by a to the power of n is equal to this multiplied by this. Now notice that if we count the total number of a's, we have m plus n in total. That means a is multiplying itself m plus n times. But we already know that when a number multiplies itself a certain number of times, we write it as an exponent or power. So this must mean that a to the power of m times a to the power of n is equal to a to the power of m plus n, which is exactly what the multiplication law states. Now let's try this out with an example. Here we have 2 to the power of 5 multiplied by 2 to the power of 3. Now according to the multiplication law, we can simplify this as 2 to the power of 5 plus 3, which gives us 2 to the power of 8 when you simplify it. Now notice that the law worked because both terms had the same base, which is very important to check first. However, for an expression with different bases, this rule won't apply. The second law we'll be looking at is called the power of a power law, and it states that when a number with an exponent is raised to another exponent, we multiply the exponent while keeping the base the same. Now let's see why this is true. Remember that b to the power of k means b is multiplying itself k times. So when we have a to the power of m raised to the power of n, it means a to the power of m is multiplying itself n times. Now notice that all these terms have the same base, which means we can apply the multiplication law, which involves adding the indices while keeping the base the same. But here's something interesting. Since a to the power of m appears n times, the exponent m is being added repeatedly n times. And we know that repeatedly adding a number n times is the same as multiplying it by n. That is why we can write this as a to the power of m multiplied by n, which is exactly what we wanted to show. Now let's try this out with an example. Here we have 2 to the power of 5 all raised to the power of 3. According to the law we just proved, we can simplify this by multiplying the exponents. So that is 2 to the power of 5 multiplied by 3, which simplifies to 2 to the power of 15. The third law, which is also the last law we'll be looking at in this video, is called the power of a product law. This law states that when the product of two numbers is raised to an exponent, we can distribute the exponent to each number in the product separately. Now let's see why this is true. Remember that an exponent tells us how many times a number multiplies itself. So if we have a times b all raised to the power of n, this means that the entire product ab is multiplying itself n times. Now notice that multiplication is associative, meaning we can regroup the terms without changing their value. So we can first multiply all the a's together, and then multiply all the b's together. Now, since we know that multiplying a number by itself multiple times follows the definition of indices, we can rewrite this as a to the power of n multiplied by b to the power of n. and that proves the power of a product law. Now let's try this out with an example. Here we have 2 multiplied by 3 all raised to the power of 5. According to the power of a product's law, we can rewrite this by applying the exponent to each factor separately. So this is equal to 2 to the power of 5 multiplied by 3 to the power of 5. Alright, in order to help you process the first 3 laws, we'll be stopping here. Now, it's important to know that the reason I'm showing you these derivations is so that you can truly understand these laws rather than just memorizing formulas. This way, even if you ever forget a law, you'll be able to derive it yourself.